The first step for the torsion test is to measure the length of the sample or the interior section of the sample. We can do this in millimeters or in inches. The test outputs all the data in metric units, so millimeters and newtons. So here I'm measuring it in millimeters. So it's about an 82 millimeter sample for that interior section. The second step is to measure the interior diameter of the sample. We can do this in a couple of different sections to see how it measures up in different locations. And this aluminum sample has about a 9.13 millimeter diameter. So we turn on the torsion test machine about 30 minutes prior to our experiment. And what you'll see here is we can change the speed that the sample will be rotated. So 50 degrees per minute, 100 degrees per minute, 200 degrees per minute, or 500 degrees per minute. And you can also change whether the sample is rotated counterclockwise or clockwise. The program that complements the machine will also give us similar ways in order to change that degree per minute or rotation mechanism. So in the top part of your program, you see it's set to 200 degrees per minute in a clockwise direction. So the first thing we do is we open this cover and we take the little input sections and we apply those to each end of the apparatus for the sample. So we can input these into the machine. So now we'll be inputting our sample into these clamps. And so we place it into the right end of the machine first because that will act as the clamp for the machine, while the left end is where the rotation will occur. And while the machine cover is open, we can rotate the left clamp of the machine in a counterclockwise or a clockwise rotation in order to have the sample fit securely into that clamp. And this runs slightly slowly in terms of being able to actually rotate it, so you might not notice the actual degree or movement in the sample too closely, but it'll rotate in the direction in order to fit the sample inside of this apparatus. Once we get the sample approximately lined up, we can fit the other end of the sample into the system, and we see that it fits securely inside of both ends. Now we tighten the left clamp and also the right clamp of the machine, and this will lock the track section and also the movement of the sample. So now we have everything in terms of the sample securely fit inside the testing system. We can take a Sharpie and we want to draw a horizontal line onto our sample. So as the sample is rotated, we'll be able to see this curve form on our sample as the torsion is applied. Once our line has been drawn on our sample, we can close the cover of the test system, and we see that the menu section comes up on the screen for the testing system. And also we can change the running procedure from the program if we like to change it that way. So if we go back to the testing system, the top or blue color is the number of degrees that is being applied at the moment, and the yellowish orange symbol is the amount of torsional moment in Newton meters that is applied to the sample at any point. So now we'll watch as the torque is applied to our sample, and we'll be able to see that the green line will create a more curved appearance as the torque is applied. If you would like to fast forward through any part of the video in terms of watching the torque actually be applied to the sample breaks at approximately 21 minutes into the video. So if you go to the 21-minute mark in the video, that's where fracture occurs, or you can fast forward any point in between to see where the sample is up to any point, or you can continue watching the sample as the sample is actually being run. As we can see now, we've had several rotations occur for our sample, and you can see that once horizontal line now appear more fluid in terms of actual curves being represented. So now if we look at the program version, so this is the program. Once the sample is completed, you can save your data. I had closed the program before this part of the video, so I'm going to show you the outcome. So after we save our data, our text data is output into a text file, and we see our angle of twist, our shear angle in radians, our torsional moment, and our time step as our sample was moved. So that will be posted on the Blackboard site, as well as this is the outcome of our sample in terms of what the machine gave us.